all had a great time at the Geek Fest yesterday night. And for those of you who braved it and made it still to the morning session, welcome. Welcome to the second day. We heard a lot about standards, industry openness yesterday, both from Evan and Andy. This morning we have Billy Cox. Billy is the director of the Cloud Builders program at Intel, and he's going to be talking about where Intel is ideas and technologies as it comes to the storage market. So please welcome Billy Cox.
Thank you and good morning. I guess I find it interesting we're at a storage conference where most people probably can't remember last night. Can anybody remember last night? You probably can until about 10 o'clock, I guess, right? So what I'm going to walk through this morning is talk a little bit about Intel's activities in the cloud, give you a sense of what we're doing. And then again, I'm going to focus specifically on storage because it's a pretty interesting story. I suspect every one of you live and breathe it, but just in case you don't, I want to walk through it and tell you a very interesting story. So there's a lot of hardcore reasons that we're here to talk about cloud. The cloud's relevant. If you're not already building a private cloud, you will be soon. If you've already built one, you're probably trying to find ways to get it integrated with the corporate culture. If you've begun that process, then what you're finding is you're being asked to go do more, deliver more capability to more scale, to more capacity. And so that evolution is pushing your data center definition, and you're somewhere along that trail. And then there's those pesky users, right, that keep expecting more and richer content. And one of the fun things I find working at Intel is that we get to take a global view. Right? It's not I have to go win in a given market segment. I have to win globally, and so I worry about the next billion users showing up with the next 3 billion devices showing up on the internet. Apparently today we've crossed the threshold where there's more devices connected to the internet than there are people. More IP addresses allocated than people accessing the internet. If you do a 10-point increase in the number of people in Asia that are connected to the internet, that's more people than live in the U.S. And so on a global basis, the demand for the kind of rich content that's becoming expected is only going to get a lot greater. And I'm not convinced that the tools in every case you need are there, but they're emerging fast. And Accenture certainly and their partners that are here, Joyent and others, are key to that role because this is warp speed evolution. And I'll argue certainly from a cloud builder standpoint that the tools you need are actually there. So this is kind of a look at some of the scary data, right? I'm sure you all have seen various forms of this. 670% growth in storage capacity shipped. It's got an annual CAGR of something like 24%. And thanks to video, thanks to a lot of us using photos and video and sharing them. But corporate data grows in enormous rates as well. And so if you look at this and you say, okay, 1,000 exabytes of traffic. I'm not even sure I know how to wrap my head around that. But if you had to go support that, if this growth continues in your enterprise today, in your internet-facing business, in your software that has to support that, are you ready to make that happen? And I will venture to wage that unless you've adopted a cloud-style architecture, unless you've adapted your IT to use partners that know how to scale, you're going to have a real challenge. And if you look at this on a global basis, one of the challenges, there's performance challenges, but Moore's Law helps us there. There are scale challenges, got some work to do there. And then there's availability challenges, but I think we know some techniques now, architectural techniques to help us get further down that path. But this scale is actually pretty scary, right? This pushes our envelope, our comfort zone. And so as Intel, we've said, if we were to look out in time, say, where do we need this to be? We call it our Cloud 2015 vision. I guess next year I have to call it 2016 or something. I'm not sure. But I call it our Cloud 2015 vision. And the idea is that we think clouds need to be federated, automated, and client-aware. Federated because IT will never have all of their cloud services and data, compute and data, in exactly one provider. By the way, I don't think it's true today. Even if you think you only have one cloud, the reality is you probably have 3 or 4 or 5 or a dozen of them, whether you're willing to admit it or not. And so if you're not thinking about that mental model, and some of them may be SaaS providers, and some of them may be infrastructure as a service providers, both internal and external. Automated, I think most of us have been working on automation for a long time, but what automation means here is consistent policy application, not meaning people aren't in the loop who can make mistakes. It gives me the scale that I need without having to add people. The first path that we took on automation was really try to simplify the steps. Take Runbook and automate it, make it a little easier. Well, automation here means I can't afford, if my business does 10x, to hire 10x the number of IT guys. I just can't do that. So how do I get a multiplier that's less than unity here, so that as I grow, the scale doesn't just kill me? I'll bet that the client-aware one probably went, what? What's that got to do with what we're talking about? But now imagine, most of us carry, at least when we're not have a microphone near us, multiple devices. We have and our car will soon be on the internet, and our TVs already are, and have multiple devices at home. How frustrating is it when you start an activity on one device and you have to shut it down and then restart the activity? And a lot of that is because the app on the, shall we say, the data center or the cloud end is simply not aware of what the device is and how you're transitioning the experience. And so we recognize that, we have to fix this. So remember, this is vision. We need applications that supported in the data center that will understand the client capability. They become client aware. So I think that's, it'd be really neat to have my kids in the car watching a movie, and then we go inside and transition it directly without having to go, or where were we in the movie? Start it over again. Of course, the kids don't mind watching it again, I suppose, so maybe it doesn't matter, but we think it does. So great to have a vision. I think we all have a vision. Maybe yours is to get some more fluids in your system, or more caffeine and sugar, I don't know. For Intel, we turn that into action by doing three things. The first is listening to customers. I know that sounds incredibly stupid, but we found that a lot of things are technology initiatives as opposed to customer initiatives. And so we Intel are helping some customers, some end users in the Open Data Center Alliance. Intel is a technical advisor, which turns out to, I thought it meant technical. I'm an engineer, right? So technical means technology, right? No, in this case it means we get to call the meetings, keep the minutes, capture the action items, fetch rocks, and those kinds of things, right? So we don't get a vote, but we kind of like what they're doing, so we're going to keep helping them. But the end user voice is coming to us in the form of usage models, and that's kind of a new way to approach the problem. I mean, if for those of you who do product development, we go talk to customers, we listen to all of their concerns and issues, we go back into our office and synthesize them as usage models so we can focus our engineering team on a problem. Well, now we have some end users telling us what they want. Huge help. The second thing is we work on new product and innovation areas. And this is pretty wide-ranging, as I'll show you in a moment, but it's doing what you'd expect Intel to do. Innovate on products. That's what we do, and we do well. Oops. The third area has to do with delivering them through cloud builders, and I'll show you more on that in a moment. The Open Data Center Alliance today is about 300 end-user IT organizations, and they represent something on the order of about $100 billion worth of IT spend. They've grown. They announced themselves October 26th last year, so I think that'd be a year ago, right? And like to the day in San Francisco downtown. And so what this tells you is this is interesting for end users. I mean, 300 people don't get together and spend this kind of time if it's not pretty valuable to them. If you're an end user IT organization and you're not a member, this is a great way to amplify your voice to the vendor community. If you're a vendor, there is a vendor tier. And they ask the end users will occasionally ask the vendors to go help them understand the technology direction or the implications of technology. They've last June published their first round of usage models. And these are end users talking, for those of you who are technology providers, this is telling us what they want. And some of these are kind of interesting, like carbon footprint reporting. Australia is now phasing in some rules for companies to have to report their carbon footprint. They're phasing in rules that not only is it the carbon footprint you directly create, but also that of your providers. So if you outsource some of your IT to an organization, you have to account for their footprint that they're doing on your behalf. So if you're a service provider in Australia, you might be aware you may get compared with somebody else, right? But what they're telling us here now is this is important to them. They want to be able to do these things. Another one they have is something they call compliance monitoring. And if you do credit card transactions, you have to support PCI, payment card industry specs. And you have to do an audit to prove that you're being compliant with the specs. And if you host your IT somewhere, you have to physically send a body out there to say, am I compliant, right? Well, I don't know about you, but if I've only got 3 people in my company, sending a body to do an audit who's, I can't afford to do that. I don't even have that skill. So what they're asking for here is I want to be able to do that through effectively an API. I need some way to do this that's not send a body to the space. As I mentioned, Intel does technology development, but we may be doing it in areas that you didn't expect. How many of you knew that you could run a data center at, 30 degrees C or 34 degrees C, hot, right? Well, you can do that, right? Your servers may sweat a lot, but it turns out that there are implications of choosing to run at high temperature ambient. There are ways that you can design motherboards, design systems, fans, the thermals of the system so that they're actually running just as reliable at 30, 34 degrees C as they would be at 18 degrees C, right? And this is an area where Intel has pioneered, worked with the industry to understand how to go do these. And I think one of the interesting examples that you all have access to is the Facebook details through the Open Compute project of their Prineville, Oregon data center. They have no supplemental air conditioning. Of course, I guess I'm based in Oregon now, and we'd like to have some warm days where you need supplemental air conditioning actually, but they don't use any supplemental air. It's all outside air. But they designed the facility from scratch to be that way. So we worked with them and other people. We've also done work on optimizing software, not just for the sake of making it run faster, but that certainly, but also to make it more power efficient and to give it more capability. And so it's not just in the chips that you'd expect from Intel, but also at the data center level. As Intel, we've also focused our work on a number of usage models. So as time passes and as we get together with partners, we bring in more usage models. I'll highlight one here because this is a storage-centric discussion around the scale-out storage. And what we wrote this list about 18 months ago. And what we realized was that if you want to build out the large-scale system, file systems are great to a point, and I think some of the partners here today can show you how to build a pretty large file system. But what we're seeing is a trend, a long-term trend toward things called object stores and key value stores and row column databases because they scale on the back end much more readily. And that's not a big percentage of storage use today. Maybe, okay, at Amazon it's probably 99% of it, but most of the world, key value stores are an emerging thing because the application has to know about the constructs of the key value store. And there are some interesting benefits. You can scale pretty easily. There are some programmer side effects. So when you write an object into a key value store, like at Amazon or other, if you immediately try to fetch it, it might not be there. It'll eventually get there, like a second or two, worst case, or typical. But it's not there immediately. But if you're building a Facebook page that I didn't get the last milliseconds worth of comments on my page, I don't care. It'll come up the next time I show the page. So these kinds of constructs, if your applications are aware, can be incredibly powerful. So we focused on a usage model around scale-out storage. And each of you have a white paper. If you don't, we can certainly get you one. They're available at the Intel table next door that shows an example of implementing that scale-out storage on 10 gigabit Ethernet using the Nexenta solution. And this is a case where we see that emerging need. And so we've built usage models around it. Now, what you'll find is, from a cloud builder standpoint, we focus on how you implement the usage model, not how you set up the software and the hardware. And this Nexenta paper is one of the classic examples of that. So Cloud Builders is something I started about, 2 years ago. We announced it formally on October 26 last year. I've got 56 published papers today across a broad category of the industry. If you're an IT organization, this is a place where you can see how these solutions work without having to necessarily buy them, install them. It gives you a chance to look behind the covers. If you have not yet built out a cloud, this will give you a great way to get some examples. Here's how it can start. We also do some, I'll put it in your words, we also do some advanced use cases like trusted compute pools, policy-based power management. We do some use cases that may be a little over the horizon for you today. That's okay. Now you can go take a look and see how they work. You can peek around the corner, right? Not often do you get to do that. And so one of the key things we did for cloud builders was, these are not marketing docs, by the way. These are technical docs, screenshots, config dumps, command lines, those kinds of things. The marketing guys kind of cringe because they don't understand most of it, and that's all right. They didn't write it for them anyway. But what we do is we actually bring these guys together, put them in a lab, and make it work. And I would love to tell you that it went that smoothly. Whoops, that's great. What did that just do? What we discovered is we need Intel is a process machine, in case somebody's not aware. Intel is a process. The Intel folks are chuckling. And so we run things through a process we call design, prove, define, prove, define, enable, prove, and scale. And I didn't even go drinking last night. The first thing we do is, with the end users, we define what solution we're trying to go after. So remember, we're starting with the usage model, not with the technology. I know that's backwards for the IT industry or the technology guys, but we actually start with the usage model and say what it is we're trying to do. And then we bring partners together to enable it. And that sounds simple, and I can pick on some names, but with very rare exceptions, do we bring a group of partners together and it worked flawlessly the first time. And so one of the benefits you get as IT organizations is, there's now been at least one of us that have tried to go build a solution rather than a bag of parts, right? And I don't claim I've solved all of the integration problems. Matter of fact, I'm pretty sure I didn't solve all that many of them at the end of the day. But at least in a few cases, I know I went deep with partners. And then we work to prove it. And prove it in this case means in a production environment. The fact that it runs in my lab is fascinating and probably interesting to some degree. Really interesting if in the complex IT world we actually make it work in your shop. Last and not least is we then make it work across the world. So it's great that it works in one or two of our customers' production environments, but to make it useful to you, it's got to work in your environment, which means we've got to make it work in thousands. And so that's why we run things through the process. And of course, the good news is we do a lot of this work, shall we say, behind the covers, in labs in Hillsboro, Oregon, or Folsom, California, or Beijing, or Shanghai. But then when we publish the paper, you get to see the results. You don't get to see all the churn, thankfully, that went on behind the scenes. So that's what we're doing, right? We work with customers, novel concept, right? Develop technology, we know how to do that pretty well. Deliver to you as a solution. Okay, that's a little bit of a tweak and kind of new. Let me focus now on specifically on how you apply this to storage. One of the challenges is transitioning from a traditional model to a new model. And what we see for storage is we're having to, did it move? We're having to make a transition. And we're trying to go from an architected, predefined, I have complete knowledge of the solution that I'm going to be deploying in advance, and therefore I can architect it. As control freaks, that's great, right? When I set up my SAN and I bring in a new Exchange server, I know how much traffic it's going to demand. I can know which ports to connect it to. I can a priori figure out all of that good stuff. Well, then some person like me walks in and says, hey, there's this way to do it called cloud. And by the way, you don't get to predict all that stuff in advance anymore because you're going to want to move things around. That's a good thing because you're going to want to take servers down. You're going to want to add new equipment that may have different performance characteristics. And then there's those darn users that are going to force your company to do new things. And now your IT group's going to be expected to respond in minutes, not days or weeks or months. And so how does the storage behave behind that? And that's where we see a shift from the predefined, highly architected storage, which makes a lot of sense in a lot of environments, don't get me wrong. But as you evolve to these more flexible environments, you're going to want to see a scale-out type solution that gives you a lot of the benefits that you expected, meaning this cross-site availability, the high availability of the storage, the tiering of storage, the dedupe, those kinds of things. You still want those, but by the way, you got to be able to scale it across sites and be able to respond and allocate in really short order. Intel's doing this internally. By the way, we have on our Cloud Builders website, you'll see details about how Intel IT is going through these steps. It's great to have an IT partner that it's an IT group, and they're as blunt with me as you are with me, right? They don't pull any punches. So the scale-out storage side has been really interesting to see the evolution, because now instead of being bound to whatever the biggest array controller is that I could architect, now if I want to double my throughput, I double the number of servers. Wow, what an interesting concept, right? And by the way, I get more availability and more storage and more throughput. Wow, is this really for real? But this architecture transition is probably one of the most important transitions that we see. And of course, probably from, and I would argue from your perspective, the best news of all is there's no special hardware. We see people doing it today, Nexenta, and there are certainly others, that do this on Intel platforms, right? And we like to see that scale, because scale drives innovation. Not just innovation in software as we see, but also innovation in platforms. I've talked to partners around the world. You will begin to see, I'll call them converged storage servers that are built out of, shall we say, commodity parts that are optimized for scale-out storage. You'll see those probably within the next year. And they're going to take these things and they're going to say, look, these boxes need compute, as I'll show you in a moment, but they also need I/O, and they need I/O of a certain form, and they need packaging and form factors and power. All of those things are now designed and optimized for that scale-out storage solution. So this is, but we as Intel aren't saying, you have to do it their way. We're saying here is some options in enabling a broad ecosystem, which, from my perspective, we want to create that dynamic in the environment. I'd just soon empower Nexenta to go innovate, and the way I do that is I create a horizontal ecosystem. So we see there's a lot of benefits here, obviously. But one of the things that I'll plant a seed in your head, that if you're building a proprietary architecture, you have to, in advance, anticipate how much compute you're going to need as the storage activities transpire. And one of the things that we found is that in scale-out storage based upon IA architecture is Moore's Law actually helps us hugely, right? Moore's Law keeps giving us more processing, which we apply smartly to compute or to I/O, whatever it might be. And now suddenly some of the things that are, shall we say, towards the top of this list that you might have said last year, wow, or 3 years ago, man, I don't think I have the horsepower to do data dedupe in line in my proprietary architecture. So you don't get it, right? You have to do some other architecture to support that. But we're now seeing solutions where, as you write the data in, it's deduped before it's actually sent to media, right? Deduped at the time of data reception, as opposed to some offline or back or precursor activity. And you see some others here, the encryption of the data, the compression of the data. These things turn out to take, CPU cycles. So as Intel, I love that. That's awesome. But for you, what it means is it keeps getting cheaper, and you get more and more capability and more performance out of that same capacity. So you might have said, wow, scale-out storage, great. It's Intel architecture, it's commodity, who cares? Well, it turns out you're going to want those features, and those are capabilities that you can get because we're using IA architecture products. So it needs compute. I wish it was as easy as write it to media, but it's a little more complicated than that. One of the other transitions that I'm sure you've watched it happen, some of you may have a laptop with an SSD, that's what Intel uses as the default now. It now takes less time to reboot my system than it does to recover from Hibernate. So Hibernate no longer makes any sense in my world, right, because of SSDs or non-volatile storage. And I know that the storage partners use SSDs as a part of their hierarchy. Some you can simply allocate volumes which are backed by SSDs. So I would argue this is actually more than just a new kind of disk drive. And I'll argue it from two perspectives. The first is, and I learned this from one of our service provider partners, he said the wear-out principles of modern SSDs are different from disk drives. And we can argue better or worse. I don't want to get into the religious side of this, but disk drives statistically will fail. Right? The head will eventually crash. Right? It might be 30 years or it might be tomorrow afternoon, but statistically that will happen. So you build your IT practices around assuming, you go and walk down the aisles looking for the red light and swap out drives every day. Actually, in Facebook in Prineville, Oregon, they do it once a week. They go walk down the aisle looking for red lights on drives. SSDs have a different failure mode, right? If you write the same data too many times to the same cells, the cells no longer recover the data, so you have to take they have to hide a lot of these realities from you. Which means, as an IT group, if I've got a bank of SSDs and a big bank of spinning media, my IT activities are going to be different. Right? I'm going to be looking for different kinds of failure scenarios on my data. And so, are you better off to have all SSDs or all drives or mixing? And that's going to be a choice you make. This particular service provider decided for this blob of storage, he was better off to have a homogeneous style of failure modes because his IT practices could be tailored for that. Right? So that's the first thing. The second thing is SSD simply, is non-volatile memory simply a drive, or is it a part of the memory hierarchy? Right? I had the wonderful career pleasure of sitting across the table from Dr. Patterson and getting to have this argument about a year ago. Right? Where does DRAM fit relative to non-volatile memory? Right? Once in your life do you get to go have that argument with somebody like him? And I think we're going to find that we're going to want to put non-volatile memory in different parts of the memory hierarchy than we have them today. Today it's primarily just as a replacement for disk drives, but what if it was somewhere else in the hierarchy? And so non-volatile memory is going to play a pretty significant role, not just because it's persistent, because guess what? It starts getting pretty fast, and it's going to show up in different parts of the hierarchy. Now, if you're an app developer company, what this means is you may find different APIs to call to let you store your data that has different characteristics. And so you may want to think about how to use it, take advantage of it. If you're a customer, you should begin to expect to see these show up and start asking yourself, how can I take advantage of these capabilities? So non-volatile memory, I think this is going to be one of those. It's not just an SSD. I sound like a commercial now. It's not just about memory, right? So we did a white paper with Nexenta. All of you have it, have the 2-page version of it in front of you. And what we set up was 2 scale-out infrastructures with replication across sites. And we actually demonstrated capacity storage, capacity volume, or storage volume on these drives. And there's a URL printed, you can't click it I guess, that'll show you how to walk you to the details of this paper. But this is a case where we actually implemented in our lab, and I guess I'll spare the editorial on whether it worked the first time. I think this was one that actually did. It worked the first time. But this is one that we actually ran. And I'll now say, okay, Intel has a vision. We work with a lot of partners. Nexenta has a working solution. You can see it today. There are others, obviously, but Nexenta's works. This is a case where it was implemented at a customer, and it's in production. And if you know KT, you can go into their site and you can get storage from them today that's backed by this store, right? Backed by this capability. Scale-out storage, commodity platforms, commodity storage. It's in production today, right? So this is not a, gee, I really, okay, great, they're giving me something over the horizon. I'll aspire to do that someday, and you go back to your day job and you're done. I would put this in your kit list of things you need to go deep on. This is real. And we have evidence from customers that they actually do these things. I love this affordable scalability of 576 terabytes. My guess is that's probably not the limit. That's probably where they chose to architect a limit at, because I know that they can easily go into petabyte scale. So this is real. This is not a lab exercise at this point. And we see certainly Xeon plays a role here. And I will submit to you that as a part of your IT technology strategy, you need to put this in the soup. So how does Moore's Law give you better and greater storage capacity? Are you planning for that? Are you asking yourself, okay, I see what I can do with a Xeon 5500 and these particular 10 gigabit NICs and these other SSDs. But SSDs get bigger, they get faster, they show up in different parts of the hierarchy. 10 gig cost goes down. We eventually see 1400 gig. The 5500 turns into 5600, which gets faster and faster over the generations. How does that impact your storage costs and your storage scale and your storage performance out 3 to 5 years out? Have you baked that into your design? I don't know if you follow the EDA industry that uses lots and lots of compute, but they live on Moore's law. Fundamentally, they've been able to double their demand, double their capacity roughly every 18 months, and they didn't have to do any work, right? They just simply took advantage of new platforms. Interestingly enough, the visualization industry, their demand has gone greater than Moore's law, so they're actually having to go and do innovations beyond the silicon. They used to live on Moore's law, now they've actually stretched it. Storage is going to benefit from Moore's law, benefit from this technology innovation as well. So I would urge you to plan that in, put that in your thinking, understand how you're going to use it. So yes, I'm a cloud evangelist. I also realize that the world has got lots of traditional storage out there and it's not going to go away anytime soon. But as you implement storage, realize that the world is changing in front of you. New technologies are available, new cost points are available. You're not sacrificing availability, you're actually getting better performance, almost certainly lower cost. And all of the IT practices around backup and archive and storage and all of those things, guess what? You're not compromising any of those. You're just implementing that particular element in a different way. One of the complaints I often hear about cloud as well, it's going to make me as a storage guy make my job go away. I'm arguing that you are uniquely aware and able to do things that still have to be done in clouds, but you're probably going to get to do them from an infrastructure perspective, meaning scale-out storage. You're also going to have to remind the developers or the DevOps guys how they need to act with storage as well. So your role may shift, but I don't think it's going to get any less important. I'll argue it's going the other way. Converged storage gives us some different ways to architect our systems. It becomes scalable, it becomes a lot more dynamic. I don't know how many of you have tried to use the APIs for key value stores like we see on Amazon S3, but as a programmer, they're really interesting. Right? Here's a blob, here's the key. When I call for it, give it back to me. And I suddenly don't have to worry about the file system overrunning. I don't have to worry about backing it up because it gets replicated on the back end. I get to set ACLs just like I would on a normal file. It's a very different approach. It's very dynamic. I don't have to control quotas on file systems. Right? It's a different kind of way to do things. And so as an alternative, I think it's very interesting. I know the old's not going to go away anytime soon. So this is Intel's direction and what we're doing broadly in the cloud. I think if you go to intel.com/cloudbuilders, you'll find some pretty amazing information on the white papers, one of which we have here. As you need to do, I guess that's a feature. As you need to do data center design for high temperature operation, as you need to do other forms of cloud, I think you'll find an amazing set of information there to help you get through that transition. And with that, I think I have time for a couple of questions. Is that true?
Yeah. Maybe we can keep it to 3 or 4 questions. So if you have a question, just raise your hand and I'll get the microphone to you.
This is what your party did last night.
Well, there's one.
It was one good party, though.
Keep things honest.
Yeah, that's right.
I think, the intelligent data storage roadmap that you have created is it's fabulous. By the way, it's one of the best presentations I've seen in a long, long time.
Thank you.
Excellent.
Thank you.
And I guess that's what, behind it is what Intel's name comes across. Excellent presentation. So the question is, the roadmap that you're creating with using processing power to do all those nice good things, compressions and erasure coding and caching and what have you, are you going to make that open standards for other people to adopt, or what is the plan of action there?
Yeah, so are we going to make this stuff open? The answer is yes. We do. We continue to do so. And we do it in a number of forms. We certainly publish information on the hardware architecture, instructions and those kinds of things. We publish those. We also know that that's not always approachable for most people to know the nuances. We put them in libraries. So in Linux, we do work in the open source community to pre-enable these into the libraries. Like OpenSSL has some accelerated instruction hardware acceleration of encryption. We've already done that work. Same thing on compression, storage libraries. So yeah, we do as much of this as we can in open source products. Absolutely.
Hi. I wondered what you could share with us about security. Yesterday there was a research paper published by, I think, the University of Rome in Germany that they had compromised Eucalyptus and a number of other cloud providers. What's Intel doing about that?
Yeah, so we're doing a lot of things, and security still remains the number one topic, right? And whether it be privacy or encryption or whatever, it's always at the top of the list. So we have chosen to put our energy behind OpenStack. Not the Eucalyptus or any of these others are bad. I'm not passing judgment. We've chosen to go do our enabling activities there, and I'm convinced that it's going to take us a while to work the kinks out of these systems. Now, OpenStack Swift has probably been through more trial and error than Nova, and so Nova will probably continue to see those. Fundamentally, what we're doing is we're saying, as an IT group, you need to be building your platforms based on what we call a hardware root of trust, so that you know what the platforms, how they've been, what platform it is, what BIOS is loaded, what hypervisor got loaded, what patches have been applied. You need to know those things. And so we have some chip-level technology, something called TXT. There's your TLA for the morning. I think I finally got one in. That lets us measure the platform at boot time and store that in another TLA, a TPM, a Trusted Platform Module, that we can then pull at post-boot time, something called remote attestation, that lets us validate through a whitelist, validate the integrity of the platform. And so what happens now, so we argue then that once you have that trusted platform, a pool of them becomes a trusted pool, and now you have some confidence in the system. Now, it's not perfect, but what it is if you decided these versions of software, this version of ESX on this platform I trust, then we can prove to you it is that version on that platform, right? So that's the first order. The second order thing is we have hardware capabilities that make sure that VMs are as isolated as we can make them today, and they get more isolated over time. But clearly hypervisors isolate, but we also have hardware checks to make sure DMA doesn't end up in the wrong namespace, and there's other hardware controls that are there. For example, to keep one hypervisor, when you start your hypervisor, you know you're the only hypervisor that's running on the box. You haven't been rootkitted. And then third and final is we do hardware acceleration for certain encryptions, like AES and some of the other modulo algorithms. We have hardware acceleration for those, and those can be 7x speedups at the raw encryption level. And we've got a lot of customers that have seen 4 and 5x speedups. Matter of fact, today on the 5600, it's faster to send HTTPS encrypted than it is to send it unencrypted on the 5500 series. Just to kind of give, so from my perspective, you might as well send your data encrypted. You pay no performance penalty now to do that. So.
Next question's over here. So Andy Beckelsteen spoke yesterday about the Open Compute project, and he mentioned that in cooperation with Intel, the wake on LAN function was overloaded to control power. That had to do with the fact that in the Open Compute project, they've decided not to integrate baseboard management controllers. So that actually seems to sort of conflict with a lot of what you were talking about there in terms of the hardware. Do you see Intel and things like the Open Compute actually sort of trying to standardize on those sorts of management features that we've all come to trust?
So clearly Wake on LAN and these others will still be there, but your question actually hits the root of the reason we like the Open Compute project, is because what Facebook is doing is they're forcing those of us, the technology vendors, to say, all of those whizzy, cool things that we had around the edge, really don't value those anymore, because I really want to do these 12 things and do them extremely well. Everything else is noise. Get rid of it. And so the fact that Wake on LAN, which is a MAC layer transaction that's not reliable, those create issues when you're trying to do these things at scale. So the Open Compute project, if you haven't followed it, is really interesting. They open source their motherboard, their chassis, and their data center designs. So you can literally go see how the Prineville data center is built. You can see what motherboards they use, what power supplies, disk drive, everything. It's all, matter of fact, you can get schematics for the boards they use. The whole thing is out there. And so we as Intel look at that and say, this is a fantastic way to go work with high density, high volume, leading edge customers and say, what do they need and how can we go address those needs? So are we going to fix Wake on LAN? I don't know. I'm not close enough to that particular one, but I know that we're actually making platform level design changes because of the Open Compute project. And I don't know what the answer to yours is, but I know we're addressing those issues. So thanks. we have time, or I think we're pretty
No more
much out of
questions.
time.
So thank you, Billy. Appreciate your presentation.
My pleasure. Thank you.